Week 13, Lesson A. Today, we're going to decide if a relation is a function. Our agenda. First, we will have a warm-up, and I'm going to ask you which one does not belong after I show you 4 pictures. Then we're going to take some notes on functions. Today, you're going to learn which stories in math make sense and which do not. We are going to practice functions using Kahoot. And then in my closure question, I'm going to ask you to describe how to tell if a relation is a function. Which one doesn't belong? Analyze the 4 representations and determine which characteristic is shared by 3 out of the 4. Write a justification for the one that doesn't belong. Today, we are going to learn about how to tell if a relation is a function. So the question you're going to ask yourself when you see a set of ordered pairs, are all the x's different? So the x is the first number in each set. So the 5, the 2, the 0, the -1. If all those numbers are different numbers, then yes, this is a function. It means it's a story in math that makes sense. Are all the x's different? I have -3, -3, 0, 4. So they are not. The -3 repeats. So this is not a function. This would be a story in math that does not make sense. Let's practice. Is this a function? Yes or no? How do you tell? Ask yourself, are all the x's different? And the answer is no. 1, 1, 4, 5. The ones repeat. So this is not a function. Is this a function? Yes or no? Ask yourself, are all the x's different? The answer is yes. The x's are 2, 4, 6, and 8. They are all different. So this is a function. You can tell if a table is a function, yes or no. You ask yourself, are all the x's different? Let's take a look at the x's in this chart or table. 3, -1, 0, 2, 3. The 3 repeats again, so this is not a function. Let's take a look at this table and decide if it's a function, yes or no. Ask yourself, are all the x's different? Let's take a look at the x's on the left. -4, -2, 1, 2, 5. They are all different. So yes, this is a function. It is a story in math that makes sense. Let's practice. Is this a function, yes or no? Ask yourself, are all the x's different? The answer is no. The x's are 1, 4, -7, 4, -1. The 4's repeat. So no, this is not a function. Is this a function, yes or no? Are all the x's different? The answer is yes. The x's are -8, -4, 0, 4, and 8. They are all different. You can also tell if a map or a mapping is a function, yes or no. You ask yourself again, are all the x's different? Sometimes on a map, it is hard to tell at first glance. So look at each individual point, perhaps. -3 maps to 0. -1 maps to 4. 2 maps to 7. 4 maps to 4. I listed out the sets of ordered pairs that I just named. -3, 0. -1, 4. 2, 7. 4, 4. Yes, this is a function because all the x's are different. Take a look at this mapping. This mapping would not be a function. Here's why. -4 maps to 4. -1 maps to -1. -1 also maps to 7. That means the -1s repeat. You can quickly tell if a mapping is not a function because it will have two arrows coming from the same x value. The -1 and the -1 repeat. And you can see these two arrows coming from the -1 value. This is not a function. Let's practice. Is this a function, yes or no? Are all the x's different? The answer is yes. There is only one line coming from each x, or one arrow. Is this a function, yes or no? Are all the x's different? The answer is no. There are two arrows coming from the 6. So that means that the points are 6, 3, and 6, 5, making the x's repeat. You can see the two arrows coming from the 6 as well. So in order to tell if a graph is a function, we can ask ourselves, are all the x's different? But there's a quick way to visually tell if that is happening, and that is to perform the vertical line test. It will tell you if this graph is a function, yes or no. So you have a graph here. It actually is a discrete graph. And you pretend to have some kind of vertical object, whether it's your finger or a pencil or an imaginary line. And you ask yourself, if I move this pencil around the board vertically, does it only hit the graph in one spot? So if I drop the pencil right here, it only hits this graph in one spot. It would only hit the graph here in one spot. It would only hit the graph here in one spot. That means as you travel down the pencil, it doesn't hit the graph twice. It only hits the graph once, no matter where you move it. So yes, okay, this would be a function. How to tell if this graph passes the vertical line test. This would be no, because if I move this pencil over here, it would hit the graph not only on the top, but also on the bottom. So if this vertical pencil is moved back and forth across this graph, it hits it somewhere twice, meaning this is not a function. Does this graph pass the vertical line test? Is it a function? Yes or no? And the answer is yes. It only hits the graph once, no matter where I move it. How to tell if this graph is a function? Does it pass the vertical line test? Is it a function, yes or no? The answer is no. because if I move the pencil over on top of this graph, it would hit the graph twice. How to tell if this graph is a function. Does it pass the vertical line test? Yes or no? And the answer is no. If I slide this pencil over on top of the graph, it would hit it in 2 spots. That means the x's repeat. How to tell if this graph is a function. Does it pass the vertical line test? And the answer is no, because when I slide the pencil over on top of this part of the graph, it would hit it here, 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 here. So that means it has multiple x's.
Vertical line test. Remember how functions aren't allowed to have more than one output value for a particular input value? Well, the vertical line test helps us see if a graph has any of those one-to-many relations that would disqualify it as a function. Here's how it works. Imagine that a vertical line is drawn on the same coordinate plane as the graph that you want to test. Then imagine moving that vertical line left and right across the domain, paying close attention to the point where the vertical line intersects with the graph. If that vertical line only intersects the graph at exactly 1 point for every possible value of x in the domain, then that means that there's only one output value for each input value. There's only one y value for each x value, so the graph qualifies as a function. Okay, so all of these graphs pass the vertical line test and are functions, but what's an example of a graph that doesn't pass the vertical line test? Well, here's one. It's the graph of our equation y squared equals x. The domain of this equation doesn't include any negative input values, so there's some places where a vertical line wouldn't intersect the graph at all, and that's okay. And there's one place where the vertical line would intersect the graph at just 1 point, which is also okay. But as we move to the right on the x-axis, you can see that our vertical line is now intersecting the curve in 2 places. That means this equation is giving us 2 possible outputs for some of its inputs, which means that it's not considered a function. Okay, now
here I have 3 relations. I have a list of ordered pairs and 2 graphs. Can you tell me one strategy I could use to determine if any of these are a function? Yes or no? Can you pick one and describe how you would tell if it is a function?